we have done, so far the statements where we have been linking tables, those were all cross products and we had to explicitly do the join. So like the question on the quiz showed, let me just shut off the, okay. So like the question on the quiz showed, you have to, if you don't explicitly join the tables by some select condition, then, every row will get hooked up with every row of the other table. So, so today I'm going to do the join. And the meaning, the way it works is exactly like the way it did in relational algebra. So let's just take a look at a query. Select first name from employee table and the department table. So if you just say employee department, it's a cross product. So now we're going to put the condition on which you're joining. So where social security number is equal to manager's social security number. So this will show you all the rows of managers, the employees who are managers. So the join condition, so this is the join condition that connects up the two tables. So this is called the inner join. And you can write it in SQL as from employee. And then you can say join department. And then you have to give the join condition. So there you're going to use on. Okay, so, and then you give the condition. So we say SSN is equal to MGR SSN. So this query is exactly identical to the query above, but now we are explicitly doing the join condition. So you're joining the two, and when you join, you have to say on what field you're linking it up. You could also have written this down as, you could also have said inner join if you wanted, but inner is, it's not necessary for you to write inner. It is, the default is inner join. So if you don't write inner, it's an inner join statement. So that's the join. So a big thing about the join when we were doing relational algebra is the natural join. So remember in the natural join, when you have two tables and where the columns are identical, so the column names are identical, then you don't even have to specify the join condition. When you do natural join, it hooks up the tables in such a way that, it looks at the two columns that have identical names, and then it does that as a matching condition. So that is called the natural join. So the star one in relational algebra, it's called so let's look at select dname dlocation. So this was the department table. I just wanted to make sure. Let's look at it. So we have dname. Okay, so if you look at this table out here, dname and department locations, the D number is exactly the same name. So that's the one that you're going to hook up with. So we have, so select dname, dlocation. From department, and then you have to write natural join. Department locations. Okay, so now when you do a natural join, you don't have to write on so-and-so key. Um, so I'm just going to give you all the different formats that are there. So natural join is, I personally really like natural join. It gives you sometimes cleaner queries. So you can rename, in case you have two tables where the columns do not have identical names, you can rename. So let's look at this next query. So we have, select, so we're going to select first name and then dependents. This is from the dependent table. So dependents name from employee, natural join. Okay, so here, because in the dependent table, if you look at the dependent table, it's called ESSN, not SSN. So I'm going to change. So I'm going to say select ESSN as SSN. Dependent name as dependent. From dependent, and then let's just call this table D. So this will do the natural join between the employee table and the dependent table. Now we called it D now. And so this table D, I have changed the name of Social Security ESSN to SSN, and I've changed dependent name to be dependent. So, and again out here, it's not, you can remove the, you don't have to write this as, you can just write it as select ESSN, SSN, dependent name, dependent from dependent. Okay, so let's look at another one where we do a rename. So let's look at this next one. So we have select F name, D name. Okay, from employee, and I'm going to do a natural join with the department table, which I'm going to rename. So I'm going to have select D name, and I'm going to do D number. Now remember the employee table, the D number is called DNO. So I'm going to rename D number to DNO from department. So, and here you can also, so you can also reduce a table. You can do the select condition. So I'm saying where D name is equal to research. Okay, so I'm listing all the employees who are in the department research by doing this query. Okay, so again, I'm going to do a few other examples. If you have any questions, just jump in. So let's look at this next query. So we have select. So I'm just a variation of the previous query, dname. from employee, natural join. And then we have okay, so I have, just 1 second, just want to just move this a bit to, don't have space out there. Okay. Okay, so I'm saying select fname, dname from employee natural join. And now I have the set D2. It's different from D1 in the only respect is that I'm also pulling out the manager's social security number. So if you're wondering why did I pull out the manager's social security number since I'm not really printing the manager's social security number, that's because I'm going to use a where condition now. So we have where okay, so here I only, so you can put the where outside, it's not necessary, depending on what kind of query you're going to do. So out here, I'm doing the join and then I'm pulling out only those um, employees whose manager is 8886. So that's another way of doing it. So, so do you understand the join? Because I don't have to really explain the join because I did that when I did relational algebra. So out here, I'm just really trying to explain the syntax and how to use it. So if you have any questions, you can ask me. Else, I'm going to keep moving with the join. So with the thing with the join, if you recall for relational algebra, I also did outer joins. But the thing in relational algebra was that outer joins are not supported in relational algebra. So the great thing is that outer joins are supported in MySQL. So I'm going to show you how to do outer joins. So in the meantime, let me just show you the different kinds of join that are allowed in SQL. So we have first the inner join, the one that I first did. That's the default one. So the word inner is not necessary. Then you have the theta join. Theta join is when the equality condition is greater or less than, could be anything. And then we have the natural join. So I've done these joins. I didn't do any theta join, but if you have a query where you have to do a condition other than equality, you can use that. So in addition, remember we did the left outer join. That was the relational algebra symbol. And so this was the left and the outer join. And then you have the right. Oh. Outer join. And then you have the full outer join. So you don't have to write the word outer. That's why I put it in parentheses. It's optional. So I'm going to just show you how to do any one of those. So again, I'll just draw the sets that we did. So we have these. Okay, so we have these sets A and B. So when you do the inner join, so this is what inner join is. The default is the intersection between the two sets. So we have, so this is set A and this is set B. And I've gone through this in relational algebra where I also gave an example of M, I think, and department table. So go back and take a look at those notes. So here I just want to show you because I've already done this with relational algebra. So this is the inner join, and the way you write the query for this would be select whatever you want to select, the attributes from A, inner join, and the inner you don't have to write. So inner join B on A dot attribute is equal to B dot attribute. So that's the inner join, and we did examples. So when we do a left outer join, so we have, just let me just copy this. Okay, so if you have a left outer join, so that the way you write this is select from A, and then we say left join B. So that's left outer join. If you want, you can write outer, and then on A dot attribute is equal to B dot attribute. So here you're going to join everything from the left set is going to come in. So we have okay, so for example, let's suppose the left set A is employee table and the right set B is the department table, which has all the manager social security numbers. So if you said that print all the employees, including those who are not managers, you can do that using the left outer join because it'll put null, for the department names, it'll put null on the right side. So similarly, we have the right outer join. So again, for set A and B. Okay, so here it's just the previous one, but now we have the set B. It'll print all the elements of set B. And again, I see here I'm just in order to, if you missed the lecture where I did outer joins and relational algebra, what I'm doing right now will not be that clear. So you need to go back and look at those notes. Because here I just want to just go over the syntax rather than explain to you what it is. And so the last one is the full outer join, where you want to get everything from both the sets, from the left and right. So that would be okay. So this is going to put everything from the left and right. It will come through. Okay, so does anyone have any questions? Okay, so now the only uh, thing that I have to mention is that MySQL, or even any of these SQLs, they have the left outer join and they have the right outer join and they have the inner join, but unfortunately they don't have the full join, the full outer join. But even though you don't have the full outer join, in MySQL, you can do that query by combining the left outer join and the right outer join. So I'll just show you how to do this in MySQL. So I just want to say is that there is no, so since you don't have a full join in MySQL, So just think about it. If you didn't have a full join, but you have a left join and you have a right join, so how would you get the full join using, given that you have a left join and a right join? Can anyone kind of think of how it could be possible? I mean, if you had to write, if you had to, have a query where you had to do something where the effect is a full join, but there is no full join. Can anyone think about how you would do it without a full join, but get the same effect using left and right? Okay, so so think about it, see, so what you really want, so you have this, so this is the left join, and you have this one, the right join. So what you really want is a combination of both of this, right? That's the full join. Okay, so how do you, is there an operator that will allow you to get both? If you want to get both this set and this set, what is the operator you would use to get this and this?
Distinct of A and
What's
B,
that?
like union.
Can you just speak up a bit? I couldn't hear you.
Using union.
Yes, that's right. You can use union. That's really what you're doing. So so let me just write that down. So that would be select. And then you use the union to hook it up. So union, and then you do the right. Sorry, this is. Okay, so you can get the full join doing union. So if you get a query, you'll have to, uh, you know, do something similar to this. And remember, unions only happen on identical sets, so you'd have to do a little bit work on the other end, but that's the basic idea, is that you can just connect, you can do a union of both of these. So let's see. Okay, so okay, now suppose all you want to get is, um, okay, so suppose all you want to get is, okay, so remember when you did the left earlier, um, we were also, when you get a left, you're getting the entire set on the left, it's including the intersection. But suppose you do not want the intersection. All you want is the part of A that, so what you want is um, um, the set A minus the set B, actually. So that's really what you want to do, because you want only those elements of A that do not belong to B. Um, so in relational algebra, remember we could do the minus. So it wasn't an issue. All you had to do was A minus B and you got your answer. But in SQL, like I mentioned earlier, there is no minus, there is no difference operator. But when I said that there was no difference operator, I said, you can do other things. SQL provides in, not in, exists, not exists, and it also provides the outer join. So in order to get A minus B, you can write it in this form. Okay, so on A dot attribute is equal to B dot attribute, but you want only those elements that belong to A but do not belong to B, right? So therefore you have to write the where condition. So where B dot attribute is null. Okay, so did you get this? So this is really A minus B. And similarly, you get B minus A, the same thing. So we have okay, so we want to get B minus A, so that would be sorry, not and where okay, so that will get you B minus A, and then when you want to get all those elements outside the intersection, so we have so now we want to get oh, so we want to get everything outside the intersection. So okay, so again, so here you can use the full join. So we have, and again, you'll have to use the union part of it, but here I'll just do it with a full join. So select this. So where A dot attribute is null, um, so will it be, okay, so also you need B dot attribute is null. But my question is that would you be writing an and or an or that connects it? Will it be where A dot attribute is null or B dot attribute is null, or is it going to be where A dot attribute is null and B dot attribute is null? What do you think? Anyone? Would it be or an and in the middle?
I think it has to be an or.
Yeah, that's right. If you do an and, you're going to get, uh, you're not going to get anything. It has to be either in set A or it has to be in set B, right? If you can't be in neither in A or B. I mean, what I meant is that the row, I mean, if it's not, it has to be an or. If you do an and, it's you're going to get an empty set. So so this was all the various options that are possible. So if you have queries where you need everything, just use the outer join where you were using minus before. It's very easy. You also, there are certain queries that you've been doing so far where you've been using either the in or not in or exist, not exist. So here you can do it. I think it's sometimes easier doing the outer join. So for example, let's look at this next query. So we have so we've done this query many times previously. So select F name from employee where not exists. Okay, so select F name from employee where not exists. Select star from dependent where SSN is equal to ESSN. So this query is listing the employees without dependents. Can you write this down using outer join? So I want you to just do it, try it out right now. List this, do this query without, by using outer join. So So you want everything from the employee set. Okay, so I mean, if you put employee on the right side, then you would be doing dependent right join emp, but that's the only difference. But if you did it using outer join, this is the way for doing the query. Okay, so does anyone have any questions? Do you understand the outer join? I mean, overall, I would say that the joins are easier, especially now that you've done relational algebra, to understand that the exist was something kind of new. The in is also a bit new that we didn't have in relational algebra. So it should be relatively, I personally think it's relatively easier than exists and the in attribute. Okay, so then the next thing I want to move you to is remember virtual tables. And I have kind of mentioned this earlier. So I want to talk about those in SQL. Very useful feature in SQL. Actually, it's also there in relational algebra. So, okay, so virtual tables are tables that are derived from the base tables. Um, and so for example, let's take my courses. There are, my courses is a relational database on the back end, and there are a lot of tables that are there on the back end, but what each of us sees is very different. So what you see when you log in is going to be every data related to you. So even let's just take for this class, the database class, when you log on to your my courses, the student view, you are seeing only where you stand in the class, you don't really see anything else about other students. When I log in, I see everyone's stuff in there. So each one of us is seeing a view of the database, the original tables. So it's an extremely useful feature to have in databases. And every user sees a different view of not the original tables. So a view, these virtual tables are derived from the base tables. So the base tables are the ones that are, when you define the database, the DDL, you are storing them. So they are not physically stored in the database. So so if they're not physically stored in the database, so you got to understand that when you are clicking, you are actually generating the table on demand. So actually it's a SQL command that you're not realizing when you click on, when you log on, is it's like a SQL command that is run and generating the view that you see. So it's generated on demand. And the motivation for doing this is, one is that, like for example, you should not have permission to see other students' records. So that's one. You don't. It's better for you not to see other stuff. So each person has their own view. So one of it is just security purposes and all that. But another reason is that um, another reason for having a view is that it is a data that are required frequently, so it's good to also keep them as views. So those are the motivations for having the view. uh, so I would say security, then data needed frequently. Why not just create a view of it instead of creating it from scratch? So the way you create a view, the syntax for it is create view. So let's see, let's create a view called work, which has the following fields: first name, last name, project. So this is the project name and the hours that you're working on the project. So it's really in the works on table where you have ESSN. I just substituted SSN for first name and last name. I'm going to write down has. So create view has, and then you write down the query that you want to do. Select. Oh, when you do view join, you can join multiple tables. So here I just realized that all the examples I did was only joining two tables, but you can join multiple tables just like relational algebra. So join works on. Okay, so that's the work. I created this table, virtual table called work. And this table is really this green colored SQL query. So that's where I joined three tables. And I have created this view. So now once you have a virtual table, you can write queries on that particular table. So we have, so I could write a query. Um, select first name as from work, where project is equal to product X. So you can write queries on the virtual table and it'll generate output. And if you, so in the database, if you give the command show tables, it will also show the work table, okay? So it'll show you all your virtual tables. So you can log out of your MySQL account and then log back in, and it'll still, the work will still be there. So the view is permanent. It's going to be there in the database. Another thing is if you update, because that's another thing. What happens if I update the base table? Or if I, just a minute. So if I update the base table, it'll also update the virtual table. And anyway, the virtual table is created on demand. And other thing, but the good thing is that if you update the table work, the virtual table, if you update, the base tables will get updated too. So that's the nice thing. Okay, so they are really very useful things to have. And like I said, they are permanent. So if you want to remove the virtual table, you'll have to give the command drop. So when you give the drop command, it will drop this work table. So that's it about views. Do you have any questions?
I'm guessing you can't insert into a view. Just update, right?
You can also insert into a view.
Oh, okay.
Yeah, but like I mentioned, you know, that if you make on most databases, there are constraints also put in. So if you violate constraints, and that'll happen not just in insert, also in update or delete, it'll affect downwards. But if you're not violating any constraints, you can insert, delete, or update.
Okay.
So they are a really, really nice feature. And so there are also, so this kind of the create view, they create virtual tables that are not really stored in the database. So they are created on demand. In relational databases, there are also tables that you can, virtual tables that are, that have a physical presence, but those tables, they don't get updated and all because so depending on what your job is, you know, depends whether one is more useful than the other. So this one, you know, because everything that you do in the virtual table gets reflected down on the base table and vice versa, they are always up to date. The other kind of table, it's not, you you have to know that that table is separate. It's not created on demand. So when you make updates to one, it doesn't reflect on the other one. So right now, I don't remember the command for that one. So, so any questions on this? Okay, so then for now, the last topic that I want to talk about in SQL is going to be aggregate functions. So I didn't do aggregate functions when I was doing relational algebra. So I'm going to do it now because I think it's a lot easier to figure out aggregate functions in SQL than it is in relational algebra, not for any reason, just because the relational algebra syntax is rather clunky. So I figured out, why go through all the pain of doing it through relational algebra when it's so much easier to teach it in SQL. So that's the last topic for now. I will do other things in SQL later, but for now, I think that will be the last topic. So we have so I'm thinking anyway, it's almost time for class. I don't want to start up something where again, I have to continue on the next class. So I might as well do aggregate functions in the next class. Does anyone have questions?